Assalamualaikum. So my name is Muhammad Adi bin Yani. So for question one, basically it asks us for the output waveform for QA, QB, and QC from the clock given. So this diagram basically it follows the output goes through the binary sequence from 0 to 7. We got 8 bits over here, and then basically this one, if you can see for the waveform, is negative 8 triggered negative triggered edge. So when clock is moving from 1 to 0, basically the output will toggle from 0 to 1 and goes over here when the second clock is going down. So it will once again toggle, so we got the output over here 0. So next, following the next output, which is QB. So now the QA is replacing the clock position, toggle as toggle indicator. So we call it as a clock pass. And then QB is toggled from 0 to 1 when the edge at QA is falling edge, which is from 1 to 0. So we got over here toggle from 0 to 1 and goes over here and vice versa. And then for QC also same, whereby now we use QB to indicate the edge movement from 1 to 0, and then goes to QC. We got from 0 to 1. Okay, mentioned over here just some inputs whereby the last output QC from the last flip-flop will be the most significant bits for the binary numbers for each falling edge, and then the first output of QA from the last flip-flop will be the least significant bit for the binary numbers for each falling edge. And question 2 basically asks us to explain more about D flip-flop, whereby D input of D flip-flop is a synchronous input because data on the input are transferred to the flip-flop's output only on the trigger edge of the clock pulse. And when D is equal to 1, then Q is 1. And the triggering edge over here, the clock pulse is set, is determined as set. And then for D is equal to 0 or D is equal to low, and Q follows same, and it's become a reset flip-flop. And for this one is basically the function of the flip-flop is to improve the SR flip-flop, whereby SR flip-flop we got output with invalid state. So when we apply the flip-flop by adding inverter at the AND gate over here, so we cut the D flip-flop, and then we may not have invalid outputs anymore. So that's settling the problem faced by SR flip-flop. And for example, assume that the positive edge triggered flip-flop is initially reset. Initially reset means the Q is 0, and for Q is 0, for cycle 1, the Q of course is 0 because D is 0, and then cycle 2, Q is also 0 because D is still 0. Why Q is 0 and why D is 0? Because basically at the rising edge over here, since this is a positive edge triggered, D is still 0 because it's not reaching 1 yet. So we count at the edge only. After passing the edge, we don't count it anymore. So we wait for clock 3. And then for clock 3, the D now is 1, then goes to Q also 1. And then after that, at cycle 4, the D is equal to 0, and then the output will be 0, and vice versa. So Q naught basically is oppositing the Q that we got, so the waveform will be like this. Okay, and last question basically asks us about the method that suitable for us to get minimum SOP for ABCD, and we basically can use KMAT to solve this issue. So by utilizing the Karnaugh map, we got output A bar, B bar, C bar, D bar plus B bar, C, D bar plus A bar, B, C plus A, B plus A, C bar, D bar. And over here we may get the correct diagram of the logic circuit.